So we've made the horizontal plan view of our roadway, and we've done the vertical elevation of the roadway as well, like a profile view using the profile tool in Civil 3D. And now we need to look at the internal uh, sections that make up a roadway. So we made our plan view and our profile views. Now we're going to kind of make our section views using the Assemblies tool in Civil 3D to create typical sections. So one of the cool things about typical sections is they represent what a section of our roadway, which is basically like an internal slice. You know, if you were to look at a cross section, what it would look like without going into the specifics of like where it's located or the exact grading and the site width. Like all of that stuff is dependent on how far along you are on the alignment, but the typical section represents, well, basically the typical view that the roadway should have. So I'm going to come and create a new file, or a copy, sorry, of a file. Call it for Assemblies, and open that up in Civil 3D. You can see this is where we left off last time. We have the alignments, they're labeled, we have the geolocation centered, and then we have our three profile views with the new elevations on all of them and the intersections showing up. So now we're going to make assemblies. So I'm just going to start by making a rectangle, and this rectangle is going to house all of our assemblies. Civil 3D is kind of wacky on object sizing. Like you can see these profiles are a pretty decent size in relation to our site, but then when we make these assemblies, they'll be super small in our drawing space. So I think it's easier to put them in a rectangle, so that way it's, you know where they are. It's easy to find them instead of having to kind of scout around. So here's my rectangle. If it's off-centered and it's itching at your OCD, sorry. Maybe I should keep it that way. So this is where I'll put all my assemblies, and to actually make an assembly, we're going to use this assembly tool here. But the assemblies are not the only thing we need. So I'm also going to go to palettes, which is here, and I'm going to open up this tool palette. And this tool palette contains a bunch of sub-assemblies or common assemblies. And the way you can think about this is a sub-assembly is a specific piece of an assembly. So like a lane, a shoulder, a curb. It's hard to see, but if you click down here at the end or the bottom of the list, you can see all of the sub-assemblies that are included in the default Civil 3D package. For example, we're going to use one of these, but you can see the different types of retaining walls, different even rail structures in Civil 3D, trench pipes. All of these are sub-assemblies, and we can put these sub-assemblies together in whatever way we like, and also change the properties of them, and all of those that we have together form an assembly. So an assembly is a collection of sub-assemblies. So here is our sub-assembly panel. Here's the assembly design tool. So now we can go into actually creating an assembly. The first assembly we're going to create is for Treehouse Drive. If you recall, Treehouse Drive is this road right here that goes between the dorms as a sort of parking and access road. So it's pretty small. And if we go to the assembly and create assembly tool, we can name our assembly. I'm going to call this Treehouse Drive. Here, we can just keep it as other and basic and all codes. We're going to mess with some of these settings in future tutorials. I'm going to hit OK, and it asks me to specify a baseline location. And this baseline location doesn't have to be, but it normally is sort of the center of your roadway. So I'm going to pop this down here, and you can see how small that is, right, compared to everything else we have here, which is why I think putting it in a rectangle like this makes it easy. Like, you can always find the rectangle, and then you know that's where all of your assemblies are. So from here, we can now add the sub-assemblies to our assembly. Now, I've already gone through and figured out where or like what pieces you guys need for all of your assemblies. So just follow along with exactly what I'm doing. If you're curious about how I came up with these, it was a mixture of looking at inbuilt subassemblies in Civil 3D as well as using Google Earth to find the actual like lane widths, for example. I used the Google Earth measurement tool to figure out how wide the lanes are. So that's where some of these numbers are coming from. So I'm going to come over here, and inside of our subassemblies panel, I'm going to find the super elevation AOR. And I believe that's this one right here. So that's in the lanes tab, lane super elevation AOR. And that's the piece we're going to use. So I'm just going to drag it, and I'm going to drop it on my assembly. Oh, sorry, I'm just going to click it and then click on the assembly. You can see this yellow square here. If I click to the right, it'll place to the right, and if I click to the left, it'll place to the left. So I'm going to click to the right, and you can see now this is our section of the road. So I'm just going to hit escape really quickly and select this roadway. If you have your properties panel open, you can see a bunch of properties about this subassembly. So you can see all of these advanced parameters, and we can change all of these. So, for example, the lane width right now is 12 feet. I'm actually going to change that to 10, if I can figure out where I can change that to 10. So I think the width is where I can do that. If I change that to 10, now you can see our width shrunk by 2 feet, which is great. You can also see that the road has a slope of 2%. So that slope is coming from the top of the road, which is called the crown, to the curb of the road. The reason that slope exists, and this exists on pretty much every road you'll drive on or you look at, is for water drainage. So if your road is flat, that means water can pool, cars can hydroplane, that is unsafe. So every road is actually sloped away from the center, so that way water flows to the curbs and into gutters and drainage systems. So this is our roadway, but I am actually going to change this default slope to be -1% instead of 2. That looks great to me. Now I'm going to add, going over to the subassembly panel again, I'm going to go to daylight options, and I'm going to select daylight general. So you can read the description here. Daylight general is a general purpose cut or fill, daylight, side slope, clear zone, and ditch. That sounds like a bunch of gibberish to me, and it probably makes even less sense to you guys. The way I like to think about daylights is daylights are essentially Civil 3D's automatic calculation of cut and fill. So what do I mean by that? Well, this is a section of a roadway. So when we assign this section to an alignment, for example, Treehouse Drive, it is going to take on elevation data, because this Treehouse Drive is defined by a profile with elevation, but this line has no width, right? It's infinitely thin, if that makes sense. Now we're assigning a cross section to that infinitely thin line right here. So there's a width. And because we're assigning a width and this has a slope of -1%, the alignment now has all of this elevation data stored into it. But what if that doesn't match with the existing surface, right? So what a daylight can do is help connect whatever design or section you're making to a surface that you already have. So this is how you can model things like ditches, slopes, retaining walls, and all of that. This will make a lot more sense in practice when we do this. So just follow along for now, but know that that's what daylight does. You can also see on the Civil 3D help page, their forums are very good, by the way. So if I search Civil 3D daylight, you can go to the daylight subassemblies. And this is a pretty good model representation of what these daylights actually mean. So for example, if you're at a roadway here and you use the basin daylight, it will create this ditch by your road, and then it'll connect to whatever surface you have automatically. So it does that for you, and you can specify things like the width of it or the grade of it, using that percentage or a slope like a 3-to-1 slope, which is something that we've talked about previously. in deliverable 3, I believe. So we're going to take this daylight general and we're going to connect it. Any red point you see is a way to connect a subassembly to an existing piece. I'm just going to select the top of the roadway here. And now you can see that it has placed in this daylight assembly. And if I click on it and I scroll down, you can see some of the properties. That has a lot of different conditional cut width properties, fill, slope properties, all of this stuff here. But in general, the most important properties are shown, and that is that it's going to connect to the existing surface using a 6:1 slope, either as a cut or a fill. And a fill means it has to add dirt or add material to get to the existing surface. And a cut means it needs to take away material or excavate material to get to the existing surface. So that's the difference between a cut and a fill, and we'll be doing a lot more work with cut and fill in deliverable 5. So I have one side of my roadway here. One of the cool things is I can actually click on these and I should be able to mirror the objects. So I can mirror it, select this center marker. I don't want it on the same side, so let me try that again. Maybe click on the outside here, and you can see it automatically mirrors it for me. So I only need to make one half of my roadway, and then I can mirror it to have both halves. So this is our Treehouse Drive assembly. I'm going to type in text to get a text box and put my text here. I'm going to put my height at like 1.5 inches and rotation angle of text at 0. And then I'm going to type in Treehouse Drive. So it's a good practice. I would label your assemblies. It's a lot easier to keep track of which assembly is which then. Otherwise, you would have to click on this center to see what assembly you're actually working with. One other quick note I want to make about why we're using this lane super elevation. If we use a different lane tool, for example, if I go back to the basic assemblies and use the basic lane, let's see, I'm just going to put this here. Don't actually do this. I'm just going to click it here so you can see. The basic lane has a set width, which for our purposes is great, 10 feet. But what happens when our lane width isn't fixed? You might be thinking, like, when does that happen? But it does. This isn't so much a problem for Treehouse Drive as it will be for Alderman and McCormick, because you can even see on the imagery, the road goes from one lane on each side, and then it slowly widens till we get this turning lane, right? The right turn and left turn lanes become separate, so the roadway has to widen. And what this lane super elevation, AOR, whatever this long name is called, does is it uses these, anything you see with the yellow triangle is essentially almost like variable. So this subassembly actually has a variable width, and it can automatically change to fit those parameters that we assign it. So that's why we're using this lane as opposed to some of the other lanes, but it's definitely possible to play around and do different things. For example, you could use the basic lane and then a transition, and then you could use 2 basic lanes to show 2 separate lanes. But I think this is easier for us to use, so we're just going to do that. Now that you have Treehouse Drive, make sure to save your project and be sure to create backups if you want. We're going to keep going. We're going to make a couple more assemblies. We're going to make 3 more. We're going to make a sidewalk road. Most of Alderman and McCormick have sidewalks on them, so we need a section view that shows that. We're going to make one that just has a sidewalk on the right, and when we get to creating our intersections, you'll see why we're doing that. And lastly, we're going to create a section using a retaining wall. Now, there's no retaining wall on O Hill or Alderman Road now, but for the purposes of this project, we're going to put it in there. I think it is a good example of how to use the assemblies and section views, and it'll also come into play for deliverable 7 when we teach you guys some geotechnical and some structural analysis. I'm going to create a new assembly now, and I'm going to call this one sidewalk road, but you can name these however you like. This is kind of a generic name because it's going to be assigned to more than one roadway. Click OK. Place it down. Now I'm going to go to my lanes and use the same super elevation AOR. This time it's going to be a 13-foot lane width. So I'm going to scroll down into my properties. Just a reminder, if you do not have your properties panel open, go to view, and then you can open your properties right here from palettes. Alternatively, from the home screen, you can also open it up from the palettes submenu. So I'm going to set my width to 13. And now I'm going to add a curb and gutter. So if I go back to basic, there should be a curb and gutter. This is great for water drainage. So I'm going to put this on the roadway, and you can see it here. It is way wider than the curb and gutter actually is on Alderman Road or McCormick Road. So I'm going to go into the advanced properties and make a gutter width of 1 foot. So you can see that shrunk it down a little bit. Now I'm also in the basic tab going to add the basic sidewalk, clicking on this top right corner, and you can see the sidewalk there, except now I'm going to also change the width. It actually looks like I don't need to change the width. 6 feet is perfect for us, so nothing to change there. And lastly, I'm going to go back to that daylighting tab and add the same daylight general. That way we can have it automatically grade our section to the surface without having to do it manually, which is really, really helpful. All right. So you can see this is starting to come together. And again, I can hopefully be able to mirror all of this at one time, which would be great. So I'm selecting all of my subassemblies, clicking the mirror button, and then selecting the left side of this square. And now you can see our full assembly made out of subassemblies. And this is just sidewalk road. So I'm just gonna do the same thing of labeling it, setting a text height, and this is our road with sidewalk, or sidewalk road. All right, we are halfway done with our assemblies, but we should be able to speed up now a little bit. I have my object snapping on, which is why it's not adjusting the way I wanted it to. Okay, now we're gonna make the same right sidewalk as what we just did here, just it will not have a sidewalk on the left side. I should be able to copy a lot of these assemblies. I think if I hit copy here, and then select all of these sub-assemblies. Ooh. Should just click and click again. Click enter. Oh, that did not work. Sorry, guys. I'm just going to create a new assembly, and we can make this from scratch. That's totally okay. One thing I can do is copy from here. I'll copy all of these. Click copy. And then paste them onto here. So this already has the lane width of 13 foot that we want, and the gutter width of 1 foot. Sorry that I switched those there. I'm going to do pretty much the same thing again of mirroring these, but I'm not going to mirror the sidewalk now because the left side of this section will not have a sidewalk. And lastly, I just need to throw on the daylight onto this curb. I actually don't think we need these either, so I'm going to delete them. Sorry about that. So this is what my right sidewalk section looks like. And I'm just going to click escape to get out of that. Oh, that did not work. I should have hit enter. Just click off of it. There we go. Just click off. And so the difference between these sections is the lack of the curb, sidewalk, and daylight. The reason why we have this is for this three-way intersection that we have here. If we assigned the section that had a sidewalk on both sides to this intersection here, then we would end up getting a sidewalk that runs through this roadway, and we don't want that. So we actually need a section that just has the sidewalk on the right. In reality, there's a roadway here too, but we're not going to model that for the purposes of this project. So that is why we made that section. The last section we're going to make has a retaining wall, and it's going to run this kind of O-hill field length of Alderman Road right here. And that works out pretty well because there's already an existing ditch here, so we wouldn't be changing too much of the existing landscape. So creating our last assembly for now, I'm going to call this retaining wall road. Really creative naming, I know. And we're going to go through and create a similar section. So I'm going to go up to our sidewalk road and copy the whole right side. That's going to stay the same. For the left-hand side, we're still going to have the road with the same width, the gutter with the same width, and the sidewalk. So I'll click on those and copy those as well. But now, instead of having the daylighting subassembly off of the sidewalk, we're going to include a retaining wall off of the sidewalk here. If I open and expand my menus, you can see that there is already a retaining wall subsection for the subassemblies here. And we're going to click on the retaining wall tapered, so the very top option here. And here we're going to put this again on the top left side. And you can see it creates a retaining wall for us. And this is really cool because it's dynamic. It will automatically change elevation as the roadway changes elevation as well. Clicking on it, you can see a bunch of properties that don't mean a lot of stuff to me or you probably. But these are things that you can play around with if you want. Just know that we're going to keep most of these on default. So a width of 0.96, a height of 1.3, 2. Instead of a 1.67 footing cover, we're going to do 4. And you can see how that's going to update here. It just makes it deeper. And then keep the key on. The key is this little piece here. If you turn it off, you can see that it can go away. But we'll keep it on. And the last thing we need to do is add a daylight here. We're going to add a different daylight than we have been though. We're going to use daylight basin off of the top side right here. And you can see this has a much more complicated layout. And this is good because it forms pretty much a ditch. And it'll do that automatically. So if you scroll down, a lot of different parameters here. We do need to change some of them, but not too many of them. We're going to change the fore slope to 2:1, so make it a little steeper. That fore slope is the one right here, closest to the assembly we attached it to. We'll keep the width at 4, the basin depth at 0, the basin slope at 4:1, then 6 feet for the basin width. The berm width, we're also going to change to 6 feet, or actually it is already 6 feet, sorry. You can play around with these values if you want to see exactly what it updates in here. Alternatively, if you go to the Civil 3D forums, you can actually see all of the parameters, their descriptions, their defaults. So this is a really good way to get a lot of information about, what Civil 3D does. So here you can see the difference between the basin slope and the basin width and what the berm actually is here. You can see the berm only happens if it's a fill instead of a cut. So all of that is stuff to use to your advantage. Now I think that's most of what we have to change besides these cut fill slopes. I'm going to change the cut slope to 1.5 to 1. And the fill slope to 2:1, just making them a little steeper. And I believe that is all we have to change here. I'm going to go ahead and move this assembly because it's starting to get pretty close to my right sidewalk assembly. I don't know if it's possible to move it without having selected all of it. It is. Cool. I'm also going to move this one just because I want it to be aligned. And I'm going to call this, lastly, name wall road. All right, so here are my 4 sections, typical sections, and we're going to assign these to our alignments to create all of our roadways. And we'll be doing that in the next tutorial. Make sure to save often.